Okay, in this question, we're required to solve this function ax cubed minus 4x squared plus bx minus 5. We know that x plus 1 is a factor, so we put x plus 1 equals to 0 and find that x is equals to minus 1. So by substituting minus 1 into the function, we obtain this: negative a, negative 4, negative b, and negative 5, which simplifies to a plus b equals to 9. Sorry, a plus b equals to negative 9. That will be our first equation. Now, we also know that when the function is divided by x minus 3, we get a remainder of 4. So in other words, we could put it as when x minus 3 is equal to 0, x equals to 3. So function of the value 3 will be equals to 4. So by substituting x equals to 3 into the function, we obtain this: 27a minus 36 plus 3b minus 5 will be equals to 4. Simplifying this, we obtain 9a plus b equals to 15. So we are solve the first and second equation using simultaneous equations to obtain the values of a and b. So solving, we obtain 8a is equals to 24, a is equals to 3, and the corresponding value of b will be negative 12. So now we want to find out the remainder when the function is divided by x minus 2. So we substitute the values of a and the values of b and the value of x equals to 2 into the function to obtain the remainder. That's because x minus 2 is equals to 0 and x will be equals to 2. So as you can see here, we substitute the values that we have found earlier in. We obtain the value of negative 21. And according to the remainder theorem, the value is negative 21. And that's your answer for the first part. As for part B, we are given this equation: x squared equals to 5 plus 2 over x. However, we cannot work with 2 over x. Therefore, we multiply throughout by x. And we obtain a cubic equation in this form. So x cubed minus 5x minus 2. To solve for the values of x, we let it be equals to 0 and we let it be a function as well. By trial and error, we found that when x is equals to negative 2, putting negative 2 into the function, we get 0. This tells us that when x is equals to minus 2, x plus 2 equals to 0, and therefore x plus 2 is a factor of the function. To solve for the other roots of the equation, we'll use the long division method. And applying the long division for the polynomial, we obtain x plus 2 multiplied by x squared minus 2x minus 1, which is the quotient. It will be equals to 0. However, we couldn't simplify this x squared minus 2x minus 1 by factorization, so we have to use the formula, the quadratic formula. So using the quadratic formula, we find two values of x corresponding to 2 plus root x over 2 and 2 minus root 8 over 2. And therefore, the three values of x are x is equals to negative 2, x is equals to 2.41 corrected to 2 decimal places, and of course x is equals to negative 0.83 corrected to 2 decimal places. That's the answer for part B. Finally, for part C, we are given this function x squared minus 6x minus 9. Further, we are told that when the function is divided by x minus p, and when divided by x plus q, they have the same remainder. So substituting function of p, the value of p into the function, and the value of negative q into the function, we are supposed to obtain the same value because we are told that we will get the same remainder according to the remainder theorem. So substituting into the functions, we obtain these expressions. P squared minus 6p minus 9 will be equals to negative q squared minus 6 times negative q minus 9. Simplifying this and applying some formulas, finally we obtain p squared minus q squared equals to 6p plus 6q. Factorizing this further, we obtain p plus q multiplied by p minus q equals to 6 times p plus q. Cancelling both sides by p plus q, we obtain what we require, which is p minus q equals to 6. And this is your answer for the part C. And thank you very much.